Good morning. Today we're going to be looking at text file IO, aka input and output in Java. As you can see in my cute little subtitles, when you want to save to a local directory. So when we're talking about IO operations, one of the things we have to actually consider is the fact that we have to have a try-catch block, because when we're talking about IO operations, we don't have access guaranteed to either the file, to the directory, to the file, the drive itself, possibly the network access, depending on what we're doing. And that's why I did the local in quotes, because when we're using this basic structure, that has to be something we can actually give a path to using our standard approach when we're working within our system itself. And so we can't guarantee that we actually have a path to that, or that we have permissions or rights to that actual file, looking at Unix permissions or the permissions that go inside a Windows box as well. But we don't have any guarantee of that. So we put inside a try block. And that doesn't mean that the code itself is going to be, can it work? No, what we have to actually look at with the try block is, can the actual code be executed? It's all good and valid code. We just don't know if it's going to be proper for the appropriate environment that we're running this code on. And so it may work in your home machine, but it might not work at school. Many students, when they're at school, have different and lower restricted rights than they do when they're in their regular computer, say, for example, at home. And so you have to actually keep that on there. The other thing we have to look at when we're working with the try-catch block is we want to make it how we you want to look at how we handle the exceptions. And when you handle exceptions, you want to handle the specific exceptions first and then proceed to more general exceptions. We're taking 2 exceptions with this that we'll be working with our code, so you can take a look at, see how you can handle different exceptions. But you could actually factor this out and handle even more exceptions if you'd like. We also want to make sure as we look at the actual direction we're working with. What we want to see also is we want to notice that the direction that we're working with these, or the actual process we're doing when we're looking at how to save or to read from a file, is that the steps involved are actually pretty much the same. It's what we do with them and how we use them. It's going to be boop, 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 or it's going to be boop, 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 boop. And so when we're looking at that, that's basically the process we're doing. We'll see that as we go through the steps of the code over here. We have a couple things we have to keep in mind. We have the path of the file, which is a string that we're going to be working with. The text that we're going to need to be saving or loading is also a string. We're going to be using a while loop on this. And we're going to repeat this process until finish. This is where we're going to use that same process of Simon Says. Again, when Simon says clap your hands, we keep on clapping our hands until Simon tells us to stop, because a while loop executes on that same process. It's repeat this until it's done. And also from our easy structure we're working with this, we'll be using a scanner, because a scanner is amazing at processing files or strings, or in fact any stream-based structure that uses text, because it's basically just an iterator. And we'll see how we work with that in just a bit. Now we do have to keep in mind the idea of our path, and so we have this lovely scene from iRobot. What's your address? 173.168.15.10? No, your local address, 127.0.1, and your physical address, 29:01:38:62. Now, what we have right here is a great example of talking about how we address the path. We either have an absolute path or we have a relative path. Now, when we see right here in the Mr. Robot clip, we have, oh, here's my address, the 173.168.15.10. That is an absolute path. That is his IP address that you would be accessing his machine to talk to it externally, because that's a public IP address. No, your local address is more like a relative path. Oh, I'm at home. And I know where home is, and you, because you're my friend, you might also know where my home is. But if I just say go down the street and talk to George, where is down the street? Who is George? We have to give a relative path. So that requires a knowledge in what we're doing, of where we are. And so most of the time when we're talking about using a path, we want to use an absolute path. And we'll see that when we talk about the information right here in just a smidge. Now, we also are going to be using static methods for this. And why are we using a Java static method? It's not oop. Yeah. Well, there's a couple things. One, explicitly there is no state. So when we're talking about a static method, there is no state to be maintained. When we're using a static method, these can be either void or some return type, but you get no access to this dot. I know. This is something that for me is just like, it's a complete and total, I have no idea why we're doing this. But when you're talking about this kind of simple little base execution thing we're working with, static methods, they might make sense. But we don't get any data members. So when you're talking about a static method, you don't get access to an external variable like, oh, I'll keep track of this, because you don't have any maintenance of state. And so you can't have a data member you'll be working with. All code you're working with, all the variables and values you're talking to, have to include either in the block of code, either as declared as a local variable for the block itself, or passed in as a parameter. And we'll be seeing that for all the methods we're working with today. We want to use a static method when we're talking about simple non-OOP code, aka non-object-oriented code. Normally, when we're talking about object orientation, we're talking about a thing that does some stuff. However, when we're looking with a static method, in the case of the file save or file read activity, we're not talking about a thing doing stuff. Rather, we're giving, here is a collection of actions that work together in this vague, structure-y thing, and we'll have action, 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 action. And so that's what we're doing with this. And so it's going to be a little bit different approach. And also when we're talking about static methods, they have to be public because we're saying class name, method. Yeah, totally different than everything we do in Java. It's special, it's weird. In fact, it's a holdover from a different style of programming. And so it's also really important to use this for things like utility operations or some calculation type things. We've been using this already in our math stuff, so math.random, math.abs, etc. We use that. And again, you have the example right below where we're saying class name dot method name and params as needed semicolon. And so we have that structure when we're working with a static method. It doesn't have an instance. I know, it's a really weird approach. And the only time we should be generally using a static method is because we don't need state. We don't have any idea of maintaining this. It's because we want to simply just call a simple set of actions that don't require maintenance information. And that's where we're going with this. So first we're going to take a look at the process of doing input with a scanner. We have the idea that we have to have a path to the file. We want to make sure that that file exists. We're going to use a scanner then to read each line from that file as a loop. And we're going to append that new line with a new line marker as well, because the next line method on the scanner consumes that new line. So when I use that .next line, that's going to eat that \n. So I want to make sure I grab that and put it in as well. We're going to take that value from next line and add it to a string variable. And we're going to use plus equals. We can't use .concat easily because if we use concat, I then have to have a much longer line where I'm going to say, oh, contents equals contents.concat, then pass that file scanner.next line, plus the \n. So I have to do much more work to use the concat because remember, strings are immutable. And so methods that put things together or squish them together, like say concat, they don't actually save it into the real variable. So if we do a whole brand new string, we have to repeat the process again and again. No, plus equals, it's the way to go. We then make sure we close our scanner and we return the string variable. Now let's go ahead and let's take a look at the actual code of that process we just looked at over here. And so as you can see right here inside the actual code, we have our public static string load file. It takes a parameter for our controller as well as the path as a parameter. And so the parameter for the controller we're using down here only at the bottom, just in case we have an error. Because again, we want to make sure we process our errors, but because we have no access to state, and because of the principle of having one thing do one thing well, in this case the I/O controller, all it does is handle static methods for dealing with I/O. And so only thing it does is just send a message back to that variable it's passed as a parameter, and it can handle the errors and do the display message and do the GUI stuff that we don't have to worry about now. So we grab that path. We create a brand new string called contents. We set equal to blank because there's nothing inside it, and we always want to make sure when we're doing a string method, we have a default value that's always A-OK. So we then have our try block. Again, as you can see, the try block has a set of squiggles that go along with it. What are inside the squiggles are the code we're going to attempt to try. We say a file is a save file, and we pass it that path. Now this path is an absolute path that we're using that goes to the file. We then create a scanner object. We check to see if the file itself exists. The .exist method is a Boolean method, obviously, that checks to see if something is there. We then instantiate the scanner. We pass the scanner the reference to that file we just created with that path. And then as long as there's something inside that scanner, because remember, a scanner is a consumptive object. As it eats things, it takes stuff away, so we want to make sure we use that. So as long as there's next stuff in there, we're going to add to our contents by grabbing next line plus the \n, what we just talked about over here on the process. And until that process is over, we repeat the process over and over and over. Again, Simon says clap your hands. And then when Simon says stop, because there's no more hands to clap, we're then going to close the scanner. We catch exceptions of I/O exception. If that error happens, we'll send it to the handle errors method of our controller. If, however, we have a different exception, just some random exception, I'm not sure which one is possibly caused, because you can get an exception thrown from the scanner file as well. It's just an exception from that. We have that passed as a generic error that also gets handled by the handle errors method. Finally, after we've caught those exceptions, we return the contents. And so that way it's like regardless, even if we have any errors, that blank contents or the actual contents of the file are then returned to us. And so that's the way the input process will go through. The saving process or output process works fairly similar. Notice, however, that we have on the header of this method, we'll start with the code this time, and when the header of this method, it's a public static void method instead of a string. Because when I'm getting output for this, when I'm saving, I'm not returning anything back. I'm just going to go do this and then I'm done. So we have on this one, we have 3 parameters instead of just the 2. Again, we start with a reference to the controller so we can have an error handled if we need it. We then have our path parameter, and this time we have the actual string parameter for the saving of the text we're going to be working with. Again, notice that we have that same try block structure that we're going to be working with on there. We attach our file name to path, and I'm using a way of building my file name so it has a reference to the date and time. So that way when I save the file, every time I have a nice, oh, here's a unique file name, and that way I don't have to handle that as part of my path rather I have my file name built on from what I'm actually working with. As you can see, this is my chatbot project, so that's where it's coming from. I then create a file just like I did earlier, where I say file, save file is a new file passing the file name. Again, that path right there gets transferred in, and I'll use it to create the file this time for a save file as well. It's almost the exact same thing. Weird. Now, I then create a scanner, but this time instead of passing the file as the scanner, or previously as we've done with keyword input, I pass the system.in. This time I'm passing a string as a parameter to the scanner constructor. Because the scanner is an amazing tool and allows us to process text in amazing ways. And this time we're just going to pass it a string, and now I can process it and use it in the exact same way without hurting the original parameter. Great stuff. Now, I think I use a print writer. Print writer I'm using because the print writer is a really easy way to write text. It's great, it's simple, and it's fast. And if you've ever done system.println, you know exactly how to use the print writer. Cool. Then we use the same while loop as long as the scanner.has next, because again, as long as there's something inside that scanner, let's keep on doing this. And then string current line equals text scanner.next line. Okay, now I don't have to worry about adding a \n this time because I have println. Print it to the line and then go back to the new line. Yes, good stuff, so we're good to go. Now, because I'm doing output, I have two different things I have to close. I have to close my text scanner and my file, my print writer. So my scanner and my file writer both have to be closed. And then again, I have that same catch where I handle the errors that I would be catching for that. Again, if we take a look at the basic process right here, I create a file from the parameter, I parse the string using the scanner, I have .has next, I loop over that, the same thing I just did earlier over on the read file. Wow, same stuff. Write one line at a time with print writer, and I close that print writer and scanner. So again, we can see right here that the structure of using a scanner to either save or to read from a file, pretty much the same thing, it's just the different steps that bounce around a bit. But the process itself is pretty simple, easy to do. We also have the ability to do the same thing, but instead of using a scanner and doing the more advanced way of doing it, we can go back to the more primitive style of doing this and using bytes to actually go and either read or write from a file. So let's take a look at the process to input from bytes. We still have to create a string variable. We still have to get that path as a variable for the parameter. We still have to check to see if the file exists. However, this time we're going to create a file input stream, which is going to go through and just read bytes. We're going to read over each byte. Now, when we read the byte, it's going to grab it as an int until we return -1. And then we'll grab that resulting byte. We'll then cast it to a char. We'll then append that char to the string that we've created already and close the file stream and return that string. So let's take a look at the code that goes along with that. Again, as you can see on that load file, it has the same two parameter thing, the app and the path we're working for, and it still returns a string. So, oh look, it's the same basic structure we saw with our previous input version. Now, where it becomes different is we look inside that if block if the file itself exists. I create a file input stream text file from that save file that I just created, similar to how we did with the scanner, but a little bit different. Then I say int result equals text file.read. So even though the file input stream does read bytes in, it returns them as an int. It gives you the int value of that byte. Because a byte is basically, well, it's an int. Yeah, because it's a number, right? Yeah. Bits are ones and zeros. Put them together and return that value. Oh, yeah, it's a number. We're good to go. So we're going to grab that int, and then we're going to cast that as a char, because really, a char is just a nice little pretty wrapper, a way of saying, oh, this number right here represents this single character value in Unicode. So this will again work with anything, not just English. So whatever that number happens to be, we'll turn it into a single character. And this works for invisible characters as well. That's why we have to make sure we do the casting separately, in fact. And so we're going to grab that, cast that letter as from char, a result. We then check to make sure the result is not -1, because if it is, then we're done. We're going to say contents plus equals the character.toString, again using that static method again. Nice little helper method that exists in the character class. .toString, passing the letter. We then are going to call the read method again, because again, we have to make sure that we continue updating our loop inside the loop itself, because that's the whole way a while loop works. Then we'll then recast letter as the char version of what result is, go through that process back in, and put it back together. And so that's how we're going through, and we'll read the file that way. And then again, we still have to close the file because we don't want to have any corrupted data. Corrupted data, bad stuff. And finally, it didn't catch the same exceptions because we're still dealing with either an IO exception or some general exception that might possibly be thrown. Same basic approach. It's amazing. Even when we're using a completely different way of reading from a file, the same structure works. Again, finally, at the very end of that, we return the contents, aka the file that we're actually reading the text from. Really nice process. Output process working with bytes. Wow, look at this. It's going to the same thing. We've got the same build a string file name. We're still going to get the scanner. Now this time we're going to go through and grab this, as long as there's something inside that string from that text scanner, we're going to take the current line, add \n to it, we're going to create a byte array. And we're going to take that current line as a byte array, is the current line.getBytes, because what that does is an amazing method where we're going to take that string and use the getBytes method, which returns the byte array of that string value. Schlop. We're going to then write that using the file output.write, which takes a byte array as a parameter, because file output string takes a byte array as that, and it automatically appends it to the end of the line. Good stuff there. Close the scanner, close our file output stream, and again we're done. The same process with output works almost exactly the same, because we're just doing the same process again. It's just, oh, I'm going to grab this byte and put it on the file. Grab the byte, put it on the file. Grab this byte, put it on the file, and it automatically appends it to the end. There are so many easy ways to do this. And this process right here, we're outputting with bytes, is almost the exact same process we'd use to go through and write something, say, for example, that's not text-based. We just have to take the byte value of whatever thing we're getting and turn that to bytes and then write that to a file. And we can write non-text-based values as well. Really pretty cool. Now, there is one new way that we have because of Java 7 Plus that we may not be using yet, but it's one of those things where, unfortunately, when we're talking about, oh, there's this really cool thing, it's this great new adventure that we have inside computer science, but textbooks, state tests, the AP exam, they may not be quite as up to date with all the cool, lovely features the language has. And so this is one of those cases where it's great, it's cool, it's amazing, but it's not in a lot of tests. But hey, we should look at it anyway because there are some really amazing features we get inside Java 7 Plus. And so the try with resources is what we're looking at this. It does require that the classes we're talking about have to implement the method. The classes we're talking about have to implement the interface auto-closable, aka they can close themselves on their own. I know, weird. Making a class name match what it's supposed to do. And it is handled actually right within the interface itself. And we then have our resources that are defined inside the parens of the try block. What, parens on a try block? We'll take a look at this in just a second. We separate multiple resources that will be auto-closed with a semicolon, and we still have the same regular cat structure. So as you can see inside this one, the save text with resources has the same three parameters we've been using with, builds the same file name just like normal. Again, the file doesn't require the catch, so we don't have to put anything inside that. However, my try with resources, I do try, and then I say scanner text scanner equals new scanner text to save, semicolon, and then print writer save text equals new print writer save file. So those two things are the closable resources. And so we'll auto-close them. As soon as I hit that closing squiggle, what's going to happen in my try block is it'll automatically close my scanner and my print writer as part of the actual structure. And this is considered a nice, clean way to handle that because we don't have to actually close them manually. They're closed explicitly as part of the try with resources. So it's a great way to actually handle that right there, right inside the actual structure of our code. Saves us a couple lines, but also we have the idea that we just have it right there. Notice my little comment in there where note the lack of .close call for both the scanner and the print writer objects because the close methods are automatically handled as part of that auto-closable interface inside the try with resources structure. Same catch happens because errors are different. It's not that it's good to try and just skip away from the errors. It's the auto-closable means we don't have to actually close that automatically. That's a more professional way of writing this new code because we're having it handled right there, right away. This is also workable with things like databases and internet connections. Hey, have that auto-close right there, right inside our try block, and we can handle those code immediately. Thanks, have a great day, and we'll see you next time.